Okay, guys, welcome back to another beautiful day of physics. Today, we're going to start on with a new chapter already, guys. We're going to move on with the, the wave physics. So in wave physics, starting off with wave physics, there are basically two main waves that you must know about, which I'm pretty sure you guys know by now. It is essentially the transverse wave and also the longitudinal wave. For those who do not know, a transverse wave will look something like this. It will look like a sine graph, right? Yeah. Okay. But it would be better if you were on time as well. Right. But anyways, yeah. Like what I was saying just now, basically you need to know of two types of wave, right? Basically a transverse wave and also a longitudinal wave. A transverse wave will basically be a sine wave that looks something like this, right? And then a longitudinal wave is basically something that is like a sound wave, right? And sound wave, they will comprise of compressions, rarefaction, then compression, and rarefaction, and so on and so on. I'm pretty sure you know this. If you ever played with a spring before, you know, like the stupid thing where you bounce back and forth. You guys know what I'm talking about, right? And near childhood, you know that thing, the thing that the spring one, the colorful one you put. Every child for sure play with you. Right, that thing. So it is basically a longitudinal wave. From here, starting off with a transverse wave, there are a few things you need to know from this transverse wave here. Basically, you need to know how to label each and every part of the wave, right? Starting off with the top here. What do you think this top part is called, by the way? Anyone knows? You still remember? You learned a little bit of this in year 9, right? But probably not very detailed. No, what's this part called? It's called the peak, right? Otherwise known as the crest, right? Either way, it's either known as the peak or the crest. The bottom part here, which I usually, a lot of students, they don't remember this, is called the trough or trough or however you pronounce it, right? And then there is essentially going to be an equilibrium position, right? This here, which is exactly in the middle of the wave, is known as the equilibrium. Equilibrium. Oh, is it double L? No, doesn't matter. All right, it's called the equilibrium. And from the equilibrium, guys, this part is important. Pay attention to this. Don't copy first. Pay attention. From the equilibrium to the peak or the equilibrium to the trough, this is something we call the amplitude. Whenever you see this word amplitude, guys, you have to understand that amplitude is responsible for the loudness of the sound. This thing here is responsible for the loudness of the sound, meaning to say, if I have a wave that has double the amplitude here, if it has double the amplitude here, it means to say it is double the loudness. Very important. This part here, they always ask you in your IGCSEs, you need to know that amplitude is directly responsible for the loudness of the sound. Okay, and then of course the next part is obviously the wavelength, right? The wavelength is also very important. The wavelength, guys, is basically measuring how long one full wave is. If let's say you start from the equilibrium position, up, down, up. Repeat, right? It starts repeating itself, right? This here is considered as one wavelength, which is represented by lambda. Okay, now it doesn't matter if you start from the equilibrium position, as long as you end back at the equilibrium position, it is the wavelength. It also can be from the peak to the peak, meaning to say here to here is also considered one wavelength, or it could be from the trough to the trough also. Here to here is also considered one wavelength. In general, guys, I want you to remember that when the wave start repeating its pattern, it is considered one wavelength. Now, a lot of students, they make this common mistake. They say that, oh, here is one wavelength and here is another wavelength. Now, you know for a fact that this is definitely not going to be true, right? Because It's not even repeating itself yet, right? This is going like up, down, down, down. Then this is down, 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 up. Then only it repeats up, down, 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 up. This here is considered as one wavelength, guys. Very important. The general rule to remember this is as soon as it starts repeating itself, it is considered as one wavelength here. And the wavelength symbol is represented by this thing, the lambda thing, which is, for those who learn Chinese, it's like the root word. Right, it's called root, right? Root as in like, 这个字是 root, right? What the hell? What the hell? 这个 banana China 这个
没有，就我们用在简体，这个字不是用。
Yeah, but yeah, yeah, this is the word So, but anyways, it doesn't matter. It's called lambda here, guys. It's what? No, the root, like root as in the Chinese word root. But it doesn't matter, that's not important, right? But yeah, the key things here to remember, these are the two things. You don't have to copy this down into your notebook, by the way, because you'll be required to copy it in your notes later on. So just pay attention, everyone. Don't copy first. Any question? I'll give you guys time to copy everything later on. Any questions or not from here? Okay, no questions. Then next, moving on, we're going to be doing the longitudinal wave. Now, longitudinal wave is also the same thing. You basically need to know how to label the whole thing, right? And if you ever think about longitudinal wave, it is essentially going to be sound wave long, right? Sound waves are longitudinal waves. You know, like how sound is traveling, right? Like for example, if I'm talking here, my voice will give energy to the air particles, pass on the energy to the air particles, and then eventually vibrate to your eardrums. That's how sound is working, right? So this is the same thing. The energy here is passed on. Okay, but that's not important. The important part here is the labeling part. Okay, the sound wave will consist of two main parts, which is known as the compression. This part here is known as compression. Okay, it is basically a region where the pressure is relatively higher. That's why the particles are much closer together. Whereas this part here, where you can see that the waves are further apart, right? This part here is known as rarefaction. Okay, rarefaction is basically a region of lower pressure. That's why the molecules are further apart, which makes sense now, right? Because the pressure is high, so it's that kind of compressing everything together, known as the compression. When the pressure is low, it's kind of like forcing the particles further away, right? So it's called a region of rarefaction. And it will be the same thing for the wavelength here as well, guys. A lot of students, they tell me that here to here is the wavelength. What's wrong with this statement here if we recall back from the previous definition of the wavelength? Yeah, it is not repeating itself yet, right? This is compression, rarefaction. Where's the repeat? Here is the repeat, right? So in reality, here to here is the wavelength, guys. Here to here is considered as one wavelength. It should be compression, rarefaction, repeat, compression, rarefaction, repeat. So it is either going to be compression to compression, or it is going to be rarefaction to rarefaction here, guys. The same concept goes as long as it is repeating itself, it is considered to be one wavelength. Okay, understand, everyone? Anyone's got a burning desire or question they want to ask? Anything? No? Bit shy on the first day, but you open up eventually. Okay, but anyways, if you have no questions, looking at the notes here, guys, let's go through it real quick. You are going to copy very soon, guys. So if you look at the first statement here, guys, wave by definition is a transference of energy through a space or object, but it does not move the particle. You'll notice that I conveniently put down these two guys here. This here is supposed to represent how sound is traveling. even though this guy is shouting, right? And then this guy from the other end can hear the sound, you'll notice that nothing has moved. The door will not move, the air particles will not move. It is basically just a transference of energy, which goes to it goes to, you know, like if you guys ever watch the Kung Fu movies, you know, there's this skill called the lion's roar. Have you guys ever heard of? It's like, if you guys ever watched Kung Fu Hustle before, you know, everything starts flying all over. That is essentially physically impossible, guys. You know, like the Kung Fu movies, like, let all the shit start flying everywhere in the direction. It doesn't work. In reality, sound will not move anything. It will only transfer energy. And because it only transfers energy, it will never move anything. So from here, you can see that it does not move the particle. They basically just transfer energy. So if you look at the statement here, energy moving from one particle of the door to the other, but the door itself has not moved. None of the particles have changed position. It will not move this here. Oh, wait, where is this page? Is on the notes, bro. Yeah, where's your notebook? It's right after the thermophysics chapter, Raj. Huh? You can't find this one? Okay, you try to find your conduction, convection, radiation chapter. It should be the next set of notes here already. It should be right after the conduction, convection, and radiation notes. You don't have this picture here, man? You're supposed to write it down, by the way. This picture that you see from me is like the completed version. Yours will be the empty version because you're actually supposed to copy and write it down. You find it now? Yeah. You try to look for this picture. It should be there. It should be there. Okay, but anyways. Like I was saying just now, so this is like probably a better drawn version of what I've talked about, all right? This is the crest, otherwise known as the peak. This is the trough, which is, in other words, the bottom of the wave, right? And then this is the amplitude, and this is the wavelength here, okay? This is what we call the equilibrium position, guys. Can you just real quickly draw down everything before I move on to the next part, guys? I'll give you like 3 minutes to draw everything nicely. You don't have to, it doesn't have to be a Picasso drawing, guys. Just draw real quick because you need this later on.
The amplitude is referring to this
Amplitude.
the sound.
Usually it will be responsible for the loudness of the sound. But don't worry, it's at the next set of notes already. The notes here at the bottom, amplitude is written here already, so you don't have to copy anything. All the important information, I've already put it in the notes already. So, yeah. Wow, 那么多个浪呢？那么多个浪，你这边还有
？Just so you go like.
Oh. Oh, direction of travel. I'll explain that later on. You just copy it down first. Oh, ignore that part. You don't need to know it. It's basically the vibration. Wavelength. Yeah, this one.
Wavelength is symbol.
Yeah, it's a symbol for wavelength. Sure, I thought you said sound travel in longitudinal wave, yet the transverse wave can make sound. Ah, very good question, Wing Yan. I was waiting for someone to ask this. Very good. Are you guys done copying, by the way? Done copying, Okay, guys. You know, like how I mentioned just now, that sound wave are supposed to be longitudinal. Hey, everyone pay attention to this. It's going to help a lot. You know, last time I said that sound waves are longitudinal waves, right? But at the top here, I said that the amplitude is responsible for the loudness of the sound. You know for a fact that sound waves are longitudinal waves, right? So how can something from a transverse wave represent the loudness of the sound? This is because, guys, all these transverse waves are basically the digitalized version of sound already, you know. If you guys ever been to a karaoke place or whatever, you know, like the microphones, right? You know what's happening to the microphone? When you talk to the microphone, it converts sound energy to electrical energy into the microphone. This electrical energy will actually transmit the data all the way to the loudspeaker, where the loudspeaker converts electrical waves to sound waves yet again, you know. So when we talk about transverse, you know, like if you shout into the microphone, sometimes you can see that bar kind of rising, right? You guys know what I'm talking about? Like you shout at it, then the bar will rise very tall. If you talk very softly, in fact, it's happening right here. You know, you see this thing here? This is essentially, right, the sound waves are being converted into electrical waves. Today, if I shout, this thing very loud, right? This thing here, this bar here, right, it keeps going all the way to the top one because it's detecting that my sound is very loud and it is representing the amplitude of the sound. If you guys ever play Discord or anything to do with the microphone, you'll notice that the bar will go up and down. That is the graphical representation of your sound, which is represented in amplitude. Of course, the louder you shout, the higher it registers. That's why it gives us a bigger amplitude. So, guys, I just want to clarify one thing only. Sound is definitely not a transverse wave. The transverse wave is just the electrical representation of your sound that was converted from sound to electric, and electric back into sound from the speaker. You guys get what I mean? Are you guys confused? Do you guys know what I'm talking about? Sure? You look confused, don't you? Which part are you confused at? Sorry? Transverse wave is not a sound wave because we know for a fact that sound waves are definitely longitudinal. This is something we have taught since year something, I don't know, right? We know for a fact this is the sound wave, right? So how come amplitude can be representing, how come this amplitude here can be representing the loudness of the sound is because this is the digitalized version of your sound. Okay, so like when we talk into the microphone, right? This microphone converts sound to electrical waves, which is represented in sine waves. The louder I shout into the microphone, the louder it detects, right? Then it will record a higher amplitude. You get what I mean? The softer I talk, it will record a smaller amplitude. So this amplitude, right, is just a representation of the loudness of the sound. It is the transverse wave is not a representation of sound wave. You get what I mean? Sure? If you have any questions, feel free to answer. No, a sound wave is definitely a longitudinal wave. Transverse wave are everything else like light wave, radio waves, water waves are transverse wave. Those are transverse wave. Sound wave is for sure longitudinal wave. You get what I mean? Good. But yeah, anyone else with any questions for this part here? Yeah. So you get the idea, right? Amplitude is just the representation of the loudness of the sound. Okay. So moving on to this next part here, right? We'll basically talk about amplitude and wavelength here, right? If you look at the statements, guys, amplitude by definition is the maximum displacement from the equilibrium. It doesn't matter if it's from here to here or it is from here to here. It is the maximum, meaning to say here to here is not the wave, it's not the amplitude. Here to here is not the amplitude. Here to here is not the amplitude because it is not the maximum, guys. This here should be the maximum distance from the equilibrium to the peak or the crest, right? It is either the height of the crest or the depth of the trough, right? Measured from the rest position. The rest position is this line here, guys, the equilibrium position, right? It basically tells you the loudness of a sound is off or not if of a sound wave, and it is measured in meters here. Okay. So yeah, I probably just need to remember this statement, and this statement here is enough really for amplitude. Okay. Then the wavelength here, yeah, let's go through it real quick. Nothing much here. It is basically the shortest distance between any points in the wave that are in phase. Like I mentioned, if you start from the crest, it will end at the crest. If you start from the trough, it will end at the trough. If it starts from the equilibrium position, it will end at the equilibrium position. All these are basically wavelengths here, right? For longitudinal waves, it is the distance between two successive compressions. Like I mentioned, it should be compression to compression or rarefaction to rarefaction, not compression to rarefaction or rarefaction to compression. Okay, not that one. So the SI units of wavelength is also in meters. Nothing much to explain here. Oh, yeah, it's okay. I'll tell you why there's a different spelling here, because in Microsoft Word, right, when typing in, the Microsoft Word follows the UK English syllable. So if you type it in the US spelling, right, you know, like color is COLOR or COLOUR, right? Yeah, one of it will be like red color line, and then the auto correct it without me noticing. But it doesn't really matter, lah. You just need to know it's meters. Right. Okay. No questions for this part here. Okay. Then this part here is important. This is basically talking about the period and also the frequency of the wavelength. Now, guys, by definition, I want to let you know that period, right, is measured in time, guys. This time is basically how long it takes for one full cycle. Okay, so let's imagine today I have a wave that there's something like this. Okay, I have a graph that tells me something like this. Okay, then they say that at the end here is like 9 seconds. Okay, if I want to find the period of this wave, assuming they are all the same, it's just fully illustrated. Assuming that I want to find the period of this wave, right, I'm basically looking for how long it takes to complete one full cycle. I repeat, a period is basically how long it takes to complete one full cycle. And if I'm looking at this graph here, how many cycles are there? 2, you sure? 1 cycle, 2 cycles, and 3 cycles here, am I right? If there's 3 cycles here and it took 9 seconds, guys, how long is my period? 3. Very good. It is 3 seconds, guys, because period by definition is the time taken, time taken over number of oscillations, okay, which in this case here, the time taken is 9 seconds and there's 3 oscillations here. That's why it's going to be in 3 seconds. Guys, I want to highlight something about this period here. The period, right, you should always remember that it is related to time, right? I don't want to say this, but it sounds a bit inappropriate because I'm a guy, right? But you can always relate it back to the female's period. It's a time, right? It's within a time frame, right? You need to remember the period is within a time frame. Then you need to remember that it is in units. Why? Because a lot of students, right, when they're doing the period, right, they'll tell me, they'll somehow they'll forget this, right? And they'll tell me the number of oscillations over the time taken. If it's number of oscillations over the time taken, it's basically 1 over second, right? 1 over second is not measured in time, guys. In fact, 1 over second is measured in frequency. So you must remember that period is associated with time. Your ultimate goal is to get time as the units at the end of the day. It should be seconds divided by number, not number divided by second. Very important on this one here. You guys understand what I'm talking about? Yeah, very important. And of course, once you understand period, looking at this statement here is quite straightforward. This is the time taken for one point of the wave to complete one oscillation. The SI units are definitely in seconds. It is the total time taken over the number of oscillations. If you want, you can draw a small little graph. You can draw a small little tree here in your graph, right? Then you say, sorry, not tree. It's 9 seconds here, right? Then from here, you can just find that the period is actually 9 over 3, which is 3 seconds at the end of the day. You can write something like that. Great, for you to remember. Okay, very important. Okay. And finally, the last thing that we want to talk about in this here before I throw you guys for some exercises is frequency. Okay. I'm pretty sure you've heard of this word frequency many times. And in fact, for some of you guys, you will even know that it is basically measured in hertz. If we think about frequency, right, let's talk about frequency in terms of its units first. Frequency has a formula of 1 over period. Okay, 1 over period, which in the previous case will be 1 over 3 seconds. 1 over 3 seconds is essentially 0.33 hertz, right, guys? Frequency, pay attention to this, is very important. You need to understand this. Frequency, right, is basically telling you how many oscillations can be completed in 1 second. Okay, how many oscillations it can complete in 1 second. If let's say I have 0.33 hertz as my frequency, it means to say every second that goes by, only 1/3 of the oscillation is complete, which makes sense because if you look back here, right, just now here was 9 seconds, right? Here's 9 seconds. Here will be 6 seconds, and here will be 3 seconds. If frequency is represented as one oscillation per second, right? It means to say if I have 0.33, 1 second will somewhere be around here, right? 1 second will be somewhere around here, meaning to say this wave only completed 1/3 of the oscillation every second only. It means to say, right, if let's say I have another wave that has an oscillation of 100 hertz, it means to say in 1 second, I can complete 100 oscillations. If I have 200 hertz, it means to say in 1 second, I have 200 oscillations. So if let's say I were to draw a graphical representation of the graph for 100 hertz, it will be probably something like this. For 200 hertz, it will be like even smaller. It will be like even smaller like this. This will be 100 hertz, and this will be 200 hertz. And all this this 100 oscillations and 200 oscillation is just in the span of 1 second. It's just in the span of 1 second. You guys get what I mean about this part here? Anyone confused? This part is important. Rachel, are you sure? Sure. This part is important. By definition, you need to remember that frequency is the number of oscillation per second. If I have a frequency of 0.33 hertz, it means to say in 1 second, I can only complete 1/3 of the oscillation. If I have 100 hertz, it means to say in 1 second, I have 100 oscillations. If I have 200 hertz, in 1 second, I have 200 oscillations. As simple as that. Okay? Very important. Okay, so if you look at the notes here, right? Frequency by definition is the number of complete waves produced per second. The SI units are in hertz. Frequency, this part is very important as well. Frequency relates to the pitch of the sound, guys. So basically, if you hear like all the men talking, right? You know what they say, right? Men in general are lazier creatures, right? If you are so lazy that even talking, we're a bit lazy. It's because we are lazy, right? Our voice box doesn't oscillate as much, you know, and because our voice box doesn't oscillate as much, we have a lower frequency. That's why we'll have a lower tone. Whereas for girls, especially for the young, excited young girls, like such as yourself, right? You always hear the loud screeching sound. That kind of scenario, right? Is because their voice box, they are so excited that the voice box is oscillating like crazy already. The higher you oscillate, the higher the frequency and the higher the pitch it is. Funny story we had when we were younger, right? Because our class was a full physics class, right? So we had very little girls in class, you know. Then we had like 3 girls in class. One of it was sitting right behind Gilbert. Gilbert is my brother for Rachel, who doesn't know. He was sitting behind my brother, and this girl had the highest pitch ever, you know. One day Gilbert got really, really annoyed, and he just turned around and said, "Hey, can you just shut up?" Wow, I thought she took it very seriously, and she was very unhappy. She was so unhappy that she changed class after that already. I'm like, wow. Wow, so serious are these girls. But yeah, obviously Gilbert was the asshole, right? But to change class because of that seemed a bit over, right? But anyways, this is how you remember, guys. Frequency, pitch, amplitude, loudness. Frequency, pitch, amplitude, loudness. Frequency, pitch, amplitude, loudness. Say that in your head a few times. Eventually you'll remember it. Amplitude, loudness, frequency, pitch. Very important. Always ask in your paper too. They will ask you something like, which one is responsible for amplitude? So which one is responsible for loudness? Which one is responsible for pitch? Or something along the lines. You just need to remember that amplitude, loudness, frequency, pitch, amplitude, loudness, frequency, pitch. Say that in your head, and you'll remember eventually. Okay, and the formula is obviously 1 over period. Sorry. Okay, fine. Okay. If you're done, let's go on to the first official formula of this chapter here, which is essentially going to be the speed of the wave. Now, speed of wave has a formula of V equals to F lambda. What does the V represent here? What does V represent? Yes, very good. It is the velocity. What's the units of velocity again? The units. Wait.
I forgot.
Hey. Abigail, what's the units? Huh? MS, no. Meters per second. Right. And obviously this F here will represent. Rachel, what does F represent? What do you think F will represent? It's not the common word we use every day. Sorry? What? Good, it is the frequency. What's the units of frequency again? Hz, which is hertz, guys. And obviously this, what's the symbol called again? Starts with an L. Lambda. Yeah, lambda. Not lambda. Is it lambda? I thought it's lambda. I thought it's lambda, but it doesn't really matter. They never test you this. It's called lambda, right? And this is representing what again? It's back to you. No, lambda.
Wavelength.
Good. It's supposed to represent the wavelength, right? And what's the units of wavelength again? Rachel? Lambda. Meters away. Very good, right? Okay, guys, I need to let you know this. Anything, hey, pay attention to this, especially for those who did not know the units here, which is okay. Whenever you're dealing with length, guys, anything to do with length, doesn't matter if it's height, width, or whatever, right? The SI units are always in meters, guys. It's the standard for all. Okay, it's always going to be in meters. Okay, okay, very important. And I also want to highlight one thing. You know, like how the units for moments are, guys. What's the formula for moments? Can someone tell me right now?
P divided by
No.
P times.
Do you guys still remember what's moments or not? Moments is the turning effect. It requires the pivot on. Right?
Moment.
Yeah. So what's the formula of moment? Do you guys still remember or not? Good. It is a force multiplied by perpendicular distance, right? One force here, one distance here, or in this case here, most of the time it will be like this and like this, right? The distance and the force. No one remembers the units for moments. Like in general, no one really will force themselves to remember this. But you know for a fact that the units for force will be in. No, what's the units for force? Oh my lord. Newtons, right? And the distance will obviously be in meters. So that's why I know for a fact that moments, guys, moments, the units is in Newton meter, right? Because it's Newton times meter. But if you look here, guys, if you pay attention to this part here, you notice that the hertz times meters, right? Shouldn't the units be like meters, hertz, or hertz, meters at the end of the day? Why in this case here it is meters per second instead of hertz meters or meter hertz? Why? Why? Think about it. No, nothing to do with that. Velocity is the standard unit size. Yes, very good, Raj. Excellent. Hertz, guys, if you recall, hertz is basically a derived unit, guys. Hertz is not a SI unit. Not SI unit means to say you need to like solve it to get it, right? Frequency, by general formula, is supposed to be 1/2, right? In other words, hertz is actually 1/2, right? If I understand that hertz is actually 1/2, then this in reality is 1/2, right? And 1/2 multiplied by meters is supposed to give you meters per second, right? Yeah, this is like the revision kind of scenario, guys. You need to know this, especially later on when you do a lot of formulas with a lot of random units. You need to know this, You understand what I'm talking about, girls? And everyone online, you understand what I'm talking about, right? Very important, you need to know this, But excellent job, Raj. You figured it out. Yeah, so from here, V is equal to F lambda is basically the formula for the wave, right? Depending on the frequency and also the wavelength, it will dictate whether it is going to be a fast wave or it is going to be a slow wave. Okay. Okay, if you have no questions, everyone. Sorry, what? No, oh yeah. If you want to say that, but usually no one does that. Don't do it. You just need to understand that hertz is in 1/2. Okay, girls, any questions? Please start doing the questions at the bottom. You have exactly 10 minutes or less. 10 minutes, Start doing the questions right now. Oh my God. For those who are online, why didn't you request for the soft copy? We took 10 seconds to complete 5 oscillations. So we send out our period and our period to be off for 5 oscillations more.
Oh, 50 seconds.
10秒用了做了5个 oscillation。你跟我讲 period 是什么呢？
period 是 time
嘛 ，right？ 给你记得是 time 嘛，所以 time 现在你觉得啦，应该是10 seconds divided by 5还是5 seconds 5 oscillations divided by
10 seconds。
哦，所以就是说 period 是2 seconds 嘛，就是说一个 wave 用了2秒来 complete， 对吗？所以如果找到 period 了，我找 frequency。
哦，可以divided by 2。
怎么divided by 2？
1 divided by 2。
哦呀，快点去formula啦！我跟你们讲这么多啊。你全部我才formula。Okay, everyone, I want to highlight this since I see a lot of you guys will do the same thing as well. Everyone pay attention to the screen right now. You know, like how all these exercises, right? I know what you guys are thinking. So easy. Just write the number down, then the final answer can already, right? This question here, let me tell you, is designed to be easy. Why is it designed to be easy? Because you know, like how Wesley they like to fail the students right from the get-go. I find that it's very demotivating, so I try not to do that. These questions are actually supposed to help you strengthen your understanding for a formula. So what you're supposed to do is, first and foremost, you're supposed to identify the parameters like a real question, right? You're going to find that, oh, this one here is wavelength. Oh, this one here is frequency. They're asking you to find the speed, right? So looking at these 3 things here, you're supposed to write V equals to F lambda. Then only you write the 20 multiplied by 12 and you'll find that it's 360 meters per second. You're supposed to do all of it and write down all the formulas for all the questions, because writing down the formulas enough time will actually help you. No need to memorize the formulas in the real exam. You'll have it in your head. You know, like how you consistently say V equals F lambda, V equals F lambda, V equals F lambda. When the exam comes, right, for some gut instinct, right, you'll remember, oh, V is equals to F lambda. Then you at least recall the formula, okay? Oh shit, very good. Excellent. That was a trick. That was a trick answer, and you are the only one to pass. But yeah, it's supposed to be 240. Stupid. Okay. Anyways, the key thing here is write down a formula, say in your head, identify the parameters for all of it. Especially for those who have just written down the numbers only. Right. Both of you are only here for maths, right? Not long maths, right?
I'm here from Max.
So what are you gonna do with it? Lunch. But your mom said you're doing MS only though, but you can go for the MS as well. I don't really matter. Hey, shoot, you're doing for your maths class now. But join like a maths class, Rico. Yeah, and MS too. Yeah.
What's the symbol for number of oscillations?
Just right hand then. Number of oscillations is right hand.
And
Yeah. Or NO dot. NO dot we represent number usually like like NO dot.
NO dot C.
这样子啊 and no then dot. So it's like period is equals to time over number of oscillations. It doesn't matter lah, the symbol doesn't really matter. It doesn't matter at all. You can even write that whatever symbol there, it doesn't matter. Oh God, what did I say? Shit, what time did we finish? What time did we say we're supposed to finish this? Guys, you have like, I see some of you guys are still not done now. You have like 4 more minutes to attempt everything. Then after that, we must discuss the answers. Oh, by the way, if you're looking at question 6 and it doesn't make sense, just ignore it. I also don't know what I'm typing. Just ignore question 6 for those who are stuck there. I don't know what I'm typing, honestly.
So what do you write?
For one to complete one oscillation. You need oscillations. The time taken to complete one oscillation is a period. So there is the time to go. For point of the way to complete one oscillation.
Sorry, I'm very
Yeah. Oh, very fast, Raj. I think you're all correct. I think, but I don't know. Let me do the calculation.
We skip question 6.
Yeah, question 6 is like, I think I was a bit, don't know what I'm doing. Might have been drunk. 2 more minutes ago. Try to attend as much as you can. I'll check Raj's answer here. Ten seconds to complete. Zero point 0.04. Oh, excellent job, Raj. You are all correct. Okay, everyone. We go check answers and see if you got anything wrong. If you're done, I think you're almost done also, right? Richard, are you done? Yeah, check answers. This guy got everything correctly. Okay, you should be able to check answers right now. Any one part of these questions you guys cannot do or not? If you cannot do, let's go through it together.
I can, I guess 0.05 and that from 5, question 5.
Question 5, 0.05.
I don't know how.
How do you get 0.05? Let's go through it together real quick, guys. If you look at this question number 5 here, right? First information you're given is the wavelength, right? And then this is your velocity, isn't it? You're asked to find the frequency, right? So it's basically V equals to F lambda, right? Whereas F is going to be V over lambda here. In this case, it's just substituting 100 with 5 only. What? How do you get something else, Chen?
I don't know.
That's why I keep saying you need to identify your parameters and write everything down. If you write everything down here step by step, it should be much easier to solve for. Oh, I saw the wrong units. You're wrong. Hey, the units is wrong now for you, Raj. It's supposed to be 20 hertz. For number 5.
Oh.
Right, frequency, frequency 当然是 in hertz one, right? Right. Rachel, question 7. Okay, let's look at the questions look at the parameters one by one first, guys. So if you look at the parameters here, first and foremost, they ask you to find the wavelength, right? So this is the first thing I know I'm looking for. They told you that the velocity is this, and it can complete 10 oscillations in 10 seconds. This is the number of oscillations, and this is the total time taken. So if I look at number of oscillations and total time taken, first thing first is I'm going to find the period, right? Which is essentially time taken over the number of oscillations, right? Which in this case here will be 10 divided by 10, which is going to be 1 second. With this period here, the next thing I want to find is frequency, right? it should be frequency is 1 over period which is in other words 1 over 1, which is still going to be 1 hertz. All right. Then finally, if I want to find the wavelength, is V equals to F lambda, right? Lambda would have been V over F, which in this case here will be 10 meters per second divided by 1, which is supposed to give you 10 meters at the end of the day. You're supposed to identify one by one your parts, then your parts here. And you should be able to solve it. Okay. Any other questions that you guys couldn't do from this part here? I think it should be quite straightforward, right? Okay, guys, we're going to stop here today. Don't lose this paper. Bring it back next week. We will continue from where we left off. There's still a huge part to cover for this wave chapter. It's a lot. So yeah, I'll see you all next week. If you have any questions, you're more than welcome to stay back for anything related to physics or some life lessons if you may. But if not, that'll be it for today, guys. I'll see you all next week. For this video? Next week? Oh yeah, sure. Bye-bye. Oi, Chai, Sanji, you guys got questions, is it? Or you guys just AFK?